Hi everyone, welcome back to another application development video of Channel Codeboard. Our today's topic is to develop a screen sharing application. You may have used different screen sharing tools already, like TeamViewer, AnyDesk, Zoom, etc. In today's video you will get to learn how to develop such an application from scratch. So, without any more delay, let's start. Let's discuss the basic architecture first. Our application will have two distinct layers, client and server. We will develop a desktop client app using Electron Js. And our server-side coding will be using nodejs. The communication between server and client will be using WebSocket protocol. Now, a screen sharing application is nothing but a video communication between two computers. And video is the series of continuous images of your screen. Correct? So, if we can capture screenshots continuously and send it to another computer, that will look like we are sharing the screen. That is exactly what we are going to develop. We will take continuous screenshots of a PC and then broadcast to other users using WebSocket. So, that is the theory part. Let's start coding now. I have created two different folders, client and server. I have opened both of these folders in WebStorm IDE. First, we'll set up the client project. To develop our client app, we will use Electron Js. Electron Js is used to create cross-platform desktop application. I am at Electron Js official website, electronjs.org. Here you will be able to see some of the popular applications, which are built on Electron Js. Now, Electron Js has very good documentation. In its official documentation page, you will get to see the steps to install Electron Js using npm. So, let's create a node project for our client and install Electron Js. Let's open the terminal. Now, we will create a node project using npm init. Let's provide the project name as Codeboard Screencast Client. Also, let's provide the entry script name as app.js. All other values we will keep as default, and finally create the project. So, our node project is created. Now, we will install Electron Js. Just run npm install Electron. Electron Js will be installed. Apart from Electron Js, for our client project, we need few other libraries also. So, let's install Socket.io client first. Socket.io client library will help us to connect with our WebSocket server. Next, we will install Screenshot-Desktop library. This will be used to take screenshots from our PC. And the final library that we will use is UUID for generating random string. All required libraries are installed now. Inside the client folder, you can notice the node modules and package.json file. Let's create the app.js. This will be the entry point for our Electron app. Now, if you go to the Electron JS documentation, you will get to see the initial app.js script. Let me copy the same and use it in our app.js. Let me explain the code here. At the very first, there are some required imports. After that, we have a function, createWindow. Correct? Inside the createWindow method, we are creating a new object of browser window. During creation of browser window, we are passing the window's width and height, along with few other properties. Finally, we are loading index.html file inside the browser window. Now, the createWindow method is being called when the app is ready. This section indicates that, if we close the window, the app should exit. Finally, this is preventing reopening a new window if we relaunch the application when app is running already. If there is no visible window, then only createWindow method will be invoked. Now, we will have to develop index.html file, which will be loaded inside the browser window. So, let's create a HTML file with name index.html. Let's provide the title, Codeboard Screencast. In the body, let's create a div with class name as header. After header div, let's create two other divs. Let's provide class for the second div as code. Also, the ID equals to code. Let's put the final divs class as container. Inside the header div, let's add some text, code board screen share. Inside container div, we will add two buttons. One is for start sharing, and another one is for stop sharing. I have added both of the buttons classes btn. Also, added two different onClick methods, start share and stop share. Our HTML structure is ready. Now, let's add a script file, index.js. Also, we will link another CSS file, style.css, in the head section. Let's create style.css and index.js files. We will add some styling first. I am fast forwarding the CSS style writing. I will add the link of all the files in video description if you want to check it out. Okay, we have done from styling point of view. Let's run the app and check how does it look like. To start the app, we have to add one line in package.json. Inside the scripts block, after test, we need to add one line. Start, Electron. That's it. Now, if we run npm start, you will be able to see the application window has appeared. But we don't need the size of the window this much big, right? Also, we don't need the menu items. Now, we will fix these. So, let's close the window and go to app.js. Let me update, the width of the window is 500 and height is 150. Also, to remove the default menu items, we need to add win.remove menu. Now, if we start the app again, we will see our latest look. So, now it looks better. Right? Here, we can see only the start button. Because, the stop button is initially hidden from CSS. Now, we will write index.js code. First, we will define a constant variable, ipcRenderer, which we will get from Electron package. I will show the use of this variable a bit later. After that, let's define window onload function. For now, just keep the function body blank. We will now define two onClick functions, start share and stop share. Inside start share function, we will invoke ipcRenderer.send with arguments start share and a blank object. Also, we need to hide the start share button and display stop share button. We can copy the content from start share method to stop share. We just need to make everything opposite. We will now send stop share. Also, we'll hide stop button and show up start button. Now, this ipcRenderer.send method will send event, along with data from HTML UI, to app.js file. We have sent two events here, start share and stop share. Now, we will write code in app.js file to handle those events. First, we have to import IPC main object from Electron package. Then, we will write a block to handle start share event. IPC main.on, start share, and then the callback function. We need to add another similar block for stop share. When the start share event is received from index.js, this callback method will be invoked. And, for the stop share event, this method will take action. Correct? Now, inside start share callback function, we need to perform two actions. First, capture continuous screenshots. Second, broadcast to all other users. If stop share event is received, we need to stop broadcasting. We will write code for these two callback methods, but before that, let's develop server-side a bit. That will help you all to to understand full structure in a better way. For the server-side coding, we will create another node project. For that, let's run npm init in the terminal. Let's provide the name as code board screencast server. I will keep everything else as it is. Now, we need to install two libraries. First one is Express. So, just run npm install express. The second library we need to install, socket.io. Okay, both of our libraries are installed. Now, let's create a file, index.js. Index.js will act as our socket server. All our clients will communicate using this socket server. Let me first write the basic structure of creating a socket server, then I will explain you. At the very top of our script, we have imported all required libraries. For socket server creation, we will use socket.io library. We imported that too. Now, in this block, we are setting up a path to serve a HTML file named display.html. Now, we have a callback function, which will be invoked when any client will be connected with the server. Finally, we have started our server on 5000 port. Our socket server, which works on WebSocket protocol, is running on HTTP. Correct? So, HTTP and WebSocket, both servers are running on 5000 port. And if we hit the path/view, we should be able to see the display.html file, which we are going to develop now. So, let's create a new file named display.html. I will add some title like Codeboard Screencast Viewer. In the body, we will add an image tag with some styling. But the image source we will not add now. That will be set dynamically. The broadcasted screenshots will be displayed here in this image tag. Let's add background color in the body also. So, that's our HTML for this file. Now, we will add few lines of JavaScript. We will use jQuery and socket.io client library in this HTML file. I collected the CDN for both of those libraries from internet. I will add all the files links in the video description. Let me copy these CDN to display.html. Inside window onload function, we will ask user to enter room ID to join in a room. If user just submit blank, then need to display an error message. Now, the obvious question is, what is a room? Okay, that is our next topic. But before that, let's run the server and check the result. To run the server, we can execute the command node index.js. You should be able to see, started on 5000. Now, if we go to browser and open localhost 5000 and then /view, the display.html page will show up. The page will ask for a room ID. If you submit blank, you will see an error message. Now, we will create a room. Room is basically a group of users. We need room because you always want to share screen only to selected users. Correct? So, the users who will be in specific room can only see the shared screen. So, let's create a room now in index.js. Let me write the code first, then I will explain. When the socket server will receive an event join message from client, then the client will be added to a specific room ID. And also we will log some text for our understanding. Now, let's go back to our client app. When user will start sharing, we will add the client to a specific room. So, let's write code in app.js. First, let's import UUID and screenshot modules. Then, we will declare two variables. Socket, which will connect with the socket server in 5000 port. This IP is my system's internal IP. I will show you the use of the interval variable a bit later. When user will click Start Share button, Start Share event will be received from UI. And this callback method will execute. So, let's write couple of lines code here. First, we are generating a UUID, which is basically some random string. Then, we are emitting join message event to server. As per our server code, if server receives a join message event, then client will be added to a room. Correct? Now, what is the room ID? That is, the randomly generated string, which we are emitting as a message, along with join message event. And, finally, the event.reply will send the generated UUID to client UI, so that we can display it. We have to write some code in index.js to receive the generated UUID and display in the UI. So, inside window onload function, we will receive the UUID event and display the data in a div with ID code. Okay, let's test it now. First, let's restart the server. As you can see, server is running on 5000 port. Let's start the client using npm init. So, our client UI has appeared. Now, if you click on Start Share, you will notice the random string. If you check the server log, you can see the message, user joined in a room, with a room ID. Now, if you want others to see your screen, you need to share this randomly generated string to other users so that they can also join to the same room and able to see your screen. Finally, we will write the last part of coding in app.js file. We will take screenshots continuously and broadcast to all clients in the same room. Let's write a set interval function to capture screenshots in specific interval. Inside the set interval, we will write code to take screenshots. So, as per this code, in each 100 milliseconds, one screenshot will be captured. Now we need to broadcast the image data to other users. Let me first write the broadcasting code, then I will explain you. Image data is binary data. Transmitting binary data using socket I/O is difficult. So, we are converting the binary data into a base 64 string. And then, we are creating a blank object. Inside the object, we are adding the room ID and base 64 image string. And, finally, we are emitting that object to socket server along with screen data event. Now, we will handle this screen data event in our server.js file. So, when the screen data event is received, then we have created the JSON object from the data string. If you could remember, we have sent the data from client, converting object to string, using JSON.stringify. Now, from the object, we have extracted the room ID and the image string. Finally, broadcasting that image string to all the users of the specific room. Now, we are at the very end of our coding. We just need to receive the image data in display.html. And dynamically set the image source. Before doing that, let me request you all, please subscribe to Channel Code Board. Your like, share, comments, and subscription motivate me to create many such interesting videos for all of you. So, let's go to display.html. We need to write few lines of code inside window.onload method. As you can see, We are dynamically setting base64 image data to image source. And we are setting that upon receiving the screen data event. Before that, we have added the client to a specific room using the room ID provided from the prompt. Finally, we are ready to test. Let's restart the server and client both. Now, start sharing. The dynamically generated token needs to be provided in browser prompt to be able to see the screen. So, let's test. So, it is working, right? I agree, not very smooth. We can do few more optimizations to make it smoother. One more thing we have to do still. That is, handling stop sharing. For that, you can just write clear interval. So, using this clear interval, we are stopping the set interval loop. So, the sharing will be stopped also. You can test it by yourself. That's it for today. In today's video, screen sharing is working, but controlling your PC from remote location is not there. So, our next video topic is, provide PC control to remote user. We will develop that, starting from this point. So subscribe to channel Codeboard to be updated on the new videos. Bye for now.